Good morning, good afternoon, good evening, or good night. Here we are with Fun with Factoring. We are going to work on factoring and look at the different ways to go about it. Following this video on the notes, you'll have several videos on manipulatives and 2 websites to go visit, as will be explained in the write-up. So let's get started. In order to do this, you'll need to have printed out your set of notes. If you have not, please pause and print it out now. So what do we mean by factoring? Well, factoring is the process in which we separate polynomial into its parts. So prior to this, we have been multiplying and putting them together. Now we're just taking them apart. So it's very much the reverse of what we have done up to this point. Alright, well, let's get started. One of the first things you want to do is look to see if you can find a greatest common factor. Often it makes it very easy to go about solving it. One of the things we can see here with our example is that we have 3a squared and 12a. Both these terms have an a attached to them. So we can look at the question, can we pull anything out? Well, I would want to pull as much out as possible. So I'm going to see, can I take a 3 and an a out of both parts? And yes, I can take 3a out of 3a and 3a out of 12a. And that will leave me with an a on the inside minus 4. Now, a common mistake the students will take out a negative. We can't do that as 3a doesn't have a negative. So we have to make sure that what we're taking out is connected to what parts. And we can look at checking by multiplying back through, or distributing back through. 3a times a, of course, is 3a squared. And 3a times negative 4 is negative 12a. Alright, so that was a fairly easy one. However, now if there are 2 terms, we need to look at some different attempts. One of the things we look here is that there are no x's, there are no x's with the second term, so it's individual. And we have an x squared with no leading number. One of the things we can look for is it the difference of squares? Are these the special case in which we have a square in the beginning and a square at the end? And of course, as the example shows, it is. And what we want to do is look at breaking that up into its components. What are the factors of x squared? The factors of x squared are x times x. And 16. Well, the factors of 16 are 1 and 16, 2 and 8, and 4 and 4. Let me write this down over here. 1 and 16, 2 and 8, and 4 and 4. Now, one of those, of course, is a perfect square, which is our 4 times 4. And we can see that as it's a negative, one of these must be negative. And with no middle term, we know that the other must be positive in order to cancel out. If we walk through this with the check, we get x squared minus 4x plus 4x minus 16. Now I have to combine like terms, and we're left with x squared minus 16, so it checks out. Now the more typical is when you run into the three terms, and we have to factor by trial and error. This basically means that we need to write down as much information as we can, and then go about trying to break this up into its parts. This is a good place where manipulatives come in, as you'll see in the other videos and in your online experience. So here we go. We're going to do our best to break this up, and the first thing I'm going to want to do is look at the factors of my leading and my end terms. So for factors of 6x squared, I need to look at 6x times x, 2x times 3x. And for my second set of terms, I'm looking at the 18. The factors of 18 are 1 times 18, 2 times 9, and 3 times 6. Alright. Now I know I'm going to break them up. This is step 2. Now this is where the trial and error comes in. Do I pick the 6x times x? Do I pick the 2x times 3x? And I'm looking at this middle term and end term and my possible factors to use for the end term. And I'm guessing that we're going to need more multiplication than just the 6 on one end and the 1. So I'm going to actually go with the 2x and the 3x. That's where I'm going to make my attempt. Okay, now step 3, of course. Now that I have placed some x's, I'm going to try to figure out which y's to use. And the same step, I'm going to look through my factors and I'm going to take a guess as to which one to use first. I don't really like the 1 times the 18 in this situation because of that middle term. So I'm going to try the 2 times 9. And now I'm going to compare and see, are we going to come anywhere close to that middle term? So I have my 2 times my 3x, which is going to give me 6x. And then my 2x times my 9, which is going to give me 18x. And if I look real quick, if I find a way to make this 6x negative, I'm going to be able to come up with that 12x that I'm looking for. I'm sorry, it's a negative 12x. So I will need to make the 18 negative to come up with the negative 12x. But that looks doable, so I will move on to the next step. In step 4, I'm going to apply the signs. So I have 2x and plus 2 and 3x minus the 9. I think that's going to work out nicely. But thinking isn't good enough, so let's go ahead and check this. 2x plus 2 times 3x minus 9. 2x and 3x is 6x squared. 2x and negative 9 is negative 18x. 2 times 3x is plus 6x. And 2 times negative 9 is minus 18. Combine like terms. 6x squared minus 12x minus 18. Yep. Check. All right, moving along. We have another example. I'm going to look at again, starting with step 1, looking at the factors of my first and last terms. And this really is a very simple one, as both sets really only have one set of factors, 1 and 3 and 1 and 5. So it makes this a little easier to do step 2. And we know there's going to have to be a 3x, and that's going to force the other one to be a regular x, or a lone x, followed by step 3. Now with this one we do have to be careful because it does work that we have those singular factors, but we don't just accept, we look to see what we get. We get 1x there and 15x there, and I look back up at my middle term. I'm shooting for a positive 14x. So between 15x and 1x, am I going to be able to get to 14x? And yes, I just have to find a way to make the 1x a negative. So in step 4, we apply our signs. And I wanted to make that 1x negative, so I'm going to make it negative 1. Okay. And we go to check. Three x times x is x squared. 3x times 5 is a positive 15x. Negative 1 times x is negative 1x. Negative 1 times 5 is a negative 5. Combine like terms. 3x squared plus 14x and minus 5. And that checks with our original. Alright. In our last bit, we are doing grouping. Now grouping is the act of picking the parts out and doing some individual manipulations. Okay, so in grouping we're going to need to separate the terms into 2 manageable bits. In this case I'm going to take b3 minus 3b squared and 4b minus 12. And I do apologize that my b's look like 6's. Unfortunately, that's just how I learned them. So bear with me. Now I'm going to look at the first grouping and ask myself, go back through the whole set of questions. Is it something I can pull out? Well, yes. I can see quickly that both of these have a b squared that I can pull out. So I can do that, and that will leave b squared b minus 3. Now with the second grouping, I can also pull out, in this case, the 4, and that's going to leave me with 4 times b minus 3. Now one of the things that you'll see is that we have a common term, the b minus 3's. What that's telling us is that from this original problem we could pull out a b minus 3. So that becomes one of our final groups. Now our second group is going to be comprised of the bits that are left. The b squared that we pulled out here, and the plus 4 or positive 4 that we have there. This is going to be our final factoring. You do have to be careful. B squared plus 4 cannot be factored through the real number system. If you use imaginary numbers, then you would be able to continue factoring this. But this could also be a term of perfect squares, as we saw back up in example number 2. If it is, then you would continue factoring out, and you would have b squared plus 4, b squared minus 4. But as I was saying, because this is a positive 4 in here instead of a negative 4, that we will not be continuing to factor it, as it doesn't factor over the real number system. Alright, if you think you've got it, we go to check mode, and we do our bit. B squared times b is b to the third. B squared times negative 3 is negative 3b squared. 4 times b is 4b. Negative 12. 4 times negative 3. Okay, and we have no like terms to combine, so let's look right over. B to the third, negative 3b squared, 4b minus 12. Check. Alright, so that's the basics on factoring. You will notice that there is quite a bit of trial and error. This set, trial of error sets, become easier for students when they have a good foundation in understanding the factoring of the normal numbers, so that they're able to break those into the component parts, as well as the understanding of the process that led up to this, the multiplication. And through the hands-on explorations that you'll see in the videos and the online experience. This is a very abstract concept, so having those online and physical manipulations are going to be very important for your student, as well as and I apologize, I just realized that may not have been on the screen for the bottom part of problem number 4. So let me go back real quick. This is problem number 4, and I'm sorry, I'm not Nick, I'm not restarting over. We had the 4 terms. We had to break them into the 2 groups and then do factoring on each group. In the first group we pulled out a b squared, which left us b squared and b minus 3. And the second group we pulled out a 4, which left us with the 4 and b minus 3. Being that the b minus 3's match, that's telling us we could have pulled that out from the original, so it becomes one of our terms. Our second term becomes what we have left, the b squared plus 4. Again, this is where you would have to look to make sure it's not a instance of the difference of squares. If it is, you would continue to factor this out. Okay? Alright, well thank you very much. Go on to the videos of the physical manipulations, the algebra blocks and the algebra tiles, and then onto your computer for the computer manipulations. Have fun.